This video is going to look at solving quadratic equations by factoring. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are just real numbers, okay, just plain real numbers. And the a cannot be equal to 0, because if you lost the a term where we have a times x squared, the equation would be linear instead of quadratic. To be able to solve a quadratic equation by factoring, we're going to use the zero product principle, which is given in your book also. If a and b are algebraic expressions such that a times b is equal to 0, then either a is going to be equal to b or b will be equal to b. In some cases, both. I'm sorry, if a is equal to 0 or b is equal to 0, excuse me, just read that completely wrong, or they may both be equal to 0, okay? So the general idea there of the zero product principle is if you've got a product and that product is equal to 0, then at least one of the factors of that product have to be 0 to make that happen, okay? So that's the general idea behind solving by factoring. Now, let me give you the steps to work in a problem like this. To solve an equation, a quadratic equation by factoring, what we're going to do is, first we're going to put it in that ax squared plus bx plus c equals 0 form. So we will get 0 on one side of the equation. Then we'll take the quadratic that's on the other side and we'll factor it. Okay? If you're a little rusty on factoring methods, you may want to take a look at the section in the preliminary chapter on factoring. It's either P5 or P4. I'm not really sure which one, but you can look back in the index of your book and see which one deals with factoring and look at that, okay? Most of the stuff that you're going to see in this section is probably going to be trinomial factorizations. The two examples that I'm going to do for you here are based on trinomials. And once you get it factored, what you're going to do is you're going to set each factor equal to 0. What that's going to do for you is give you a couple different basic linear equations to solve. You'll solve those two and you'll get your answers. Okay? You can check the solutions to these, but these do not require being checked. There's nothing about solving a quadratic by this method that causes you to get answers that don't work unless you make a mistake when you're working it. So checking it is completely up to you. All right, let's take a look at an example with just a very basic quadratic that won't be very hard at all to factor. The instructions here would say something like solve by factoring. Okay, I'm just going to write solve in this particular case. X squared plus 3x minus 10 is equal to 0. Okay? So we already have the 0 on one side of the equation. I don't have to move anything. I don't have to simplify, do anything to the equation itself. I already have the 0 on one side. Okay? So my next step is to factor the quadratic. That's the x squared plus 3x minus 10 part over here. Okay? And again, if you're a little rusty on factoring, you can check out the preliminary section that deals with that in the book. You can look at some videos online. Just Google factoring quadratics. Or you can come by and see me and we'll look at a few and I'll try to help you sort of shake your memory loose a little bit on how to factor these pretty easily. All right, so if you don't have a leading coefficient on that x squared term, the factorization is pretty easy. We're just going to put an x in both of those first positions in the two factors. Then we're going to figure out what two factors of negative 10 would combine to give me a positive 3. Since the two signs are different, and the last one is a negative, we know that the two factors will need to be opposite sign. One will be positive, one will be negative. And that the larger of the two needs to be a positive since our middle term is a positive 3. So for 10, that means what two factors of 10 can we subtract to get that positive 3. So 10 doesn't have a lot of factors, just 1 and 10 and then 5 and 2, and it's going to be the 5 and the 2. The larger of those two factors, of course, is the 5, so it will get the plus, and the 2 will get the minus. You can double check your work here by foiling back out to make sure you get the quadratic that you started with. You may already know from past algebra classes whether you have a lot of trouble with factoring or not, so you probably have a good sense of whether you really need to check that or not. Now from here we've got it factored completely, and so the next step would be to go in and set the individual factors equal to 0 and then solve. So if we subtract on this first one, we subtract 5 from both sides, x is going to be equal to -5, and then x is equal to +2 there. So those are our two answers. On WebAssign, of course, you'd enter them both in the blank with a comma separating them. All right, let's do another one. This one we're going to have a leading coefficient on the x squared so that you can see a little bit more how you might deal with one like that. And again, the instructions would just be to solve by factoring. We've got 12x squared minus 41x plus 24 equals 0. So this time we have to consider factors of the leading coefficient, which is the 12, and factors of the constant, both. Okay. For this trinomial, I've got a positive constant, a positive c term, the 24 there at the end. My middle term is negative. The positive 24 tells me that the two factors of 24 will both be the same sign. And then the fact that the 41 is negative tells me that both factors will be negative. Okay, so at least we know that going into it. And then what we want to do is think about what the factors of 12, 1 and 12, 2 and 6, 3 and 4, and the factors of 24, 1 and 24, 2 and 12, let's see, 3 and 8, 4 and 6. Okay, and we want to consider, we'll have to have a product. We'll actually have to have two products of one set of factors for 12 with one set of factors for 24. And then the two products we get from that I'll have to add to give us that -41 in the middle. Okay, and so you can do this by trial and error, and this is a lot of factors to tackle, I know, but what you'll want to do is just kind of go through them one at a time, one set at a time, and see which one will give you the right combination to get the 41 in the middle. Let me go through one first that doesn't work so you can kind of see what happens with that, and then I'll show you the correct factorization too. This is the way I set this up, and this is a lot larger than I would normally do it too, just so y'all can kind of see a little bit better what I'm doing. I'm going to pick the factor pair 2 and 6 from the 12, and then I'm just going to pick the 2 and 12 from the 24. Okay, the first set comes from the leading coefficient, the second set comes from the constant. And like I said, different people do these different ways. What I do next is I multiply on the diagonal. In this case, it would be 2 times 12. And let me go ahead and change one thing here. We did say that 24 would need two negative factors, so let's go ahead and make both of those negative, since we know that off the bat. 2 times -12 would give me a -24, and then 6 times -2 is going to give me a -12. Then what you do, see, this would give you the two products that you get in the middle when you are foiling two binomials out. And these would need to add together to give you that -41x. Well, when I put these two together, I get -36. So that's not right, okay? That's not the right combination. What you can do then, if you want to, is just swap them, okay? We could swap these out and say, all right, well, that didn't work. So what about 2 and 6 if I swap up the products? All right, so that would give me a -4. And a -72. Too big this time, okay? So that one's way bigger than 41 instead of the other way around. And as you can see, this gets kind of tedious if you have to go through all of the different sets and combine them with each other and then flip to see, what other products you could get. It can take a while on some of these that have larger numbers of factors. The correct setup for this one is 3 and 4 from the leading coefficient of 12, and -8 and -3 from the leading coefficient, or not from the leading coefficient, but from the constant of 24, okay? Now, the way I figured out that this is what it was supposed to be was, since that middle term is negative 41, I knew that at least one of the two products would need to be an odd number, okay? And that's where I kind of got the 9 from here. We're going to get a 9 when we multiply the 3 times the negative 3, and a negative 32 when we do 4 times negative 8. Combine these two by addition, and you get negative 41, okay? So that's the right set. Now, how do I figure out which one of these goes with which one to put them into the factors, okay? So here's what I do. And this is kind of the reason why I use this whole cross thing when I do the multiplication on the diagonal like that. And that's because if you'll set it up like that, then the two numbers that are in a horizontal row with each other, they go in the same factor. So for example, from this one, my first factor would be 3x minus 8. And my second factor will be 4x minus 3. Okay, and I just read it straight across like that. If you choose not to set it up like that, you'll want to set it up some way so that you can check those two products and their sum to make sure you get that middle term correctly, okay? However you want to set it up. Like I said, there's a zillion different ways to show this factorization, so if you were taught something different, that's fine, okay? This just happens to be the way I do it. All right, now that we've gotten through all of that finally, let's take our two factors, now that we've completely forgotten what we were doing in the beginning of the problem. 3x minus 8 equals 0, and 4x minus 3 also equals 0. We want to solve for x, so add 8 to both sides. So 3x is equal to 8, 4x is equal to 3. Divide both sides by the coefficient, so x is 8/3. And x is 3/4. And there you go. There are your two answers from this one.